In the year 1902, in a limestone hillside about 150 miles south of Cairo, a team of British archaeologists found a clay pot. It was sealed, buried in a rock-cut tomb that had not been opened since before the first pyramids were built. Inside the pot, curled with his knees pulled up to his chin, was a man. He had been dead for nearly 4,800 years. The pot, the tomb, and the cool limestone around him had done something almost no Egyptian tomb does. They had kept his bones, and the DNA inside his bones in good condition. The archaeologists shipped him to England. He sat in a museum in Liverpool for over 100 years. He survived 2 world wars, including the Nazi bombing of Liverpool during the Blitz, which destroyed most of the other human remains in the same collection. He outlasted his curators, and then, in July of 2025, scientists pulled the very first complete genome of an ancient Egyptian from one of his teeth, and his story finally came back to life. To understand why this single discovery is such a big deal, you have to understand what Egyptian DNA has put scientists through for the last 40 years. Ancient Egypt is the most studied ancient civilization on Earth. Archaeologists have spent more than 2 centuries pulling tombs, temples, papyri, and mummies out of the desert. We know what pharaohs ate, what gods they prayed to, and how they wrapped their dead. But for almost all of that time, we have known almost nothing about who the ancient Egyptians actually were, biologically. The reason is the heat. Egypt's climate, the same dry warmth that preserves linen and papyri so beautifully, is brutal on DNA. Genetic material breaks down faster in warm conditions, and mummified tissue, contrary to popular belief, is rarely a good source. The chemicals used in mummification damage the strands. The wrappings trap heat. Most attempts to extract ancient Egyptian DNA, going back to the first try in 1985, have ended in either failure or contamination. In 2017, a team finally managed to get partial genetic data from 3 Egyptian mummies recovered from a site called Abuzer el Melek, about 100 kilometers south of Cairo. It was a milestone. But there were 2 big problems. First, the data was incomplete, limited to between 90,000 and 400,000 specific genetic positions, not the full sequence of a true whole genome. Second, the mummies were too late. All 3 came from the 3rd intermediate period, the era from about 700 BC to the time of Christ. By that point, Egypt had already been invaded by Libyans, Nubians, Assyrians, Persians, and Greeks. Its population had been mixed and remixed. What scientists really wanted was a dynastic Egyptian, someone from the time of the pyramids before the foreign invasion. For decades, that sample did not exist. Then, in 2025, the team led by Adeline Morez Jacobs at Liverpool John Moores University, along with collaborators at the Francis Crick Institute in London, finally had it, the whole genome, the Pyramid Age. Older than any Egyptian DNA ever sequenced by 1,500 years. The man at the center of the study was excavated by a British team in 1902. The lead archaeologist was John Garstang, working through the Egypt Exploration Fund. Garstang would later become one of the major figures in Mediterranean archaeology, but at this point in his career, he was still building his reputation. His team was working at a site called Nuwayrat, a necropolis carved into the limestone cliffs along the eastern bank of the Nile. The tomb they opened belonged to a man whose name is lost. The Egyptians of his era did not always inscribe names for ordinary citizens, only for the elite, and even then, not all of those inscriptions have survived. What they did do was bury him with care. His body had been placed inside a large ceramic vessel, knees folded against his chest, sealed shut, and then placed inside a rock-cut chamber carved into solid limestone. That combination of ceramic pot and limestone tomb turned out to be one of the luckiest accidents in the history of paleogenetics. The pot kept moisture and microbes away from the body, the limestone kept the temperature stable, and critically, the burial took place before artificial mummification became standard practice in Egypt. No chemicals, no wrappings, no drying processes that damage DNA, just a body in a sealed pot in a stable, cool stone chamber. The dating placed his death somewhere between 2855 BC and 2570 BC in the transition between Egypt's early dynastic period and the start of the Old Kingdom. To put that in context, he died at roughly the same time the first pyramids were being constructed at Saqqara and Giza. The man in the pot was a contemporary of the people who built the Great Pyramid. After Garstang's team finished the excavation, the burial was donated by Egypt's Antiquities Service, which was operating under British colonial control at the time, to the Liverpool Institute of Archaeology. The man was shipped across the Mediterranean, packed into wooden crates, and brought to England. He stayed there for the next century. The collection was eventually transferred to World Museum Liverpool. In the 1940s, during World War II, German bombs hit Liverpool repeatedly. The museum took direct damage. Most of the human remains in the collection were destroyed. The man in the pot somehow survived. He was now in his second great act of preservation. The first had been the ceramic pot in the desert. The second was the dust and rubble of a bombed-out British museum. By the time Morez Jacobs and her colleagues at the Crick Institute approached the World Museum in the early 2020s, the man had been sitting in storage in Liverpool for more than 120 years. His skeleton was partial but informative. Most importantly, his teeth were intact. Teeth are the gold standard for ancient DNA extraction. The enamel forms a hard shell that protects the dental pulp inside, where genetic material can survive for thousands of years, even in conditions where bone DNA has already broken down. Roots, the parts of the tooth buried inside the jawbone, are even better because they are sealed off from oral bacteria and outside contamination. The team took a single tooth from the man's jaw, and from its root, they extracted DNA. Then they sequenced it using a technique called shotgun sequencing, which reads every fragment of genetic material in the sample, not just specific target regions. After processing, the data covered the man's genome at what geneticists call 2 times coverage, which is low by modern standards, but enough to reconstruct the full sequence with confidence. The result was the first complete genome of an Old Kingdom Egyptian. It was published in the journal Nature on July 2, 2025. Adeline Morez Jacobs, the lead author, described what the team had achieved. Piecing together all the clues from this individual's DNA, bones, and teeth, she said, had allowed them to build a comprehensive picture of one ancient Egyptian's life. They could tell where he grew up. They could tell what kind of work he did. They could tell roughly how old he was when he died. But the most important thing they could do, the thing nobody had ever done before for an ancient Egyptian, was look at his complete genetic ancestry and ask where his people had come from. The answer surprised them. When the team compared the man's genome to ancient and modern populations from across Africa, the Middle East, and Europe, they expected to find that most of his ancestry traced back to North Africa. That part proved correct. About 80% of his genome matched the genetic signatures of ancient North African Neolithic populations, especially groups related to Moroccan Neolithic individuals from sites like Tafaralt and Ifri Namr o Musa. These were the descendants of the earliest North African farming communities, populations that had spread across the southern Mediterranean and the Nile Valley thousands of years before the pyramids. But the remaining 20% was different. That 20% traced back to a region called the Eastern Fertile Crescent, an arc of land that today covers parts of Iraq, Iran, Turkey, and Jordan. Above all, it traced back to Mesopotamia, the land between the Tigris and Euphrates rivers, where some of the world's first cities had risen during the same centuries that Egypt's first kings were unifying the Nile. This was the bombshell. Archaeologists had suspected for over a century that ancient Egypt and Mesopotamia had been in contact. They had found signs of it in the artifacts, Egyptian pottery styles influenced by Mesopotamian designs. The earliest forms of writing emerging in both regions at almost the same time with similar conceptual structures. Cylinder seals, a Mesopotamian invention, appearing in early dynastic Egyptian tombs. The evidence had always pointed to some kind of exchange between the two great river valley civilizations, but the question had always been what kind of exchange? Was it just trade? Did goods and ideas move along ancient land and sea routes without the people moving with them? Or did entire populations actually migrate from one region to another? Until the new Weyrat genome, there was no biological evidence to settle the question. The new Weyrat man settled it. 20% of his ancestry was from the Eastern Fertile Crescent. Somewhere in his family tree, going back generations, there were ancestors who had not been Egyptian. They had walked or sailed into Egypt from somewhere east of the Sinai Peninsula. The trade routes between the two civilizations had not just carried pottery and writing systems. They had carried people who had stayed, mixed with local Egyptian populations, and become Egyptians themselves. The team was careful. They could not say from one individual exactly when the migration had happened. The DNA evidence shows the result of mixing across multiple generations, not the moment it started. But they had now proven something that thousands of dig sites and pottery fragments had only been able to imply. Egypt was, from its founding centuries, a melting pot. While the genetic team worked on the genome, a parallel effort was underway in Liverpool to do something else nobody had ever managed before for an old kingdom Egyptian. They were going to put a face on him. The work was done by Caroline Wilkinson, professor of craniofacial identification at Liverpool, John Moores University, and one of the most experienced forensic anthropologists in the world. Wilkinson runs a facility called the Face Lab. She has reconstructed the faces of Richard III of England, Robert the Bruce of Scotland, Ramesses II, and Cleopatra's sister Arsinoe IV. The new Weyrat man would join that list, but with one important difference. For the first time, the reconstruction would be guided by the subject's actual DNA. Wilkinson started with a high-resolution, three-dimensional scan of the skull. From the bone structure alone, she could rebuild the major features. The jawline, the cheekbones, the eye sockets, the nose. These are the parts of the face that follow skull anatomy closely, and forensic anthropologists can predict them with reasonable accuracy. The harder parts are the soft features, the ears, the exact shape of the lips, the thickness of the hair, if any. For these, the genetic data could help. The team ran the man's genome through a tool called the HiRESplex system, which predicts hair, eye, and skin pigmentation from DNA. The results suggested he most likely had brown eyes, brown hair, and skin pigmentation that ranged from dark brown to black. Those were the best estimates based on the genome itself. Wilkinson, however, made an unusual choice. She presented the final reconstruction in grayscale, without coloring in the skin or the hair. The reason was scientific caution. Pigmentation predictions from ancient DNA carry uncertainty, and Wilkinson did not want viewers to mistake the team's best guess for a definitive image. As she made clear when the reconstruction was unveiled, this face represents only one individual and should not be taken as representative of all ancient Egyptians. What emerged was the face of a real man, a man with a strong, weathered jawline, a long face with prominent cheekbones, a serious, careful expression. He looked, in Wilkinson's careful rendering, like exactly what he probably was, a man who had worked and worked hard for his entire adult life. That was the second discovery. The man's bones told a story that nobody had expected. He had been about 160 centimeters tall, which is roughly 5'2" by modern measures. He had died somewhere between the ages of 44 and 64, an unusually advanced age for a man of the Old Kingdom. Most ancient Egyptians did not live that long. His teeth were heavily worn. His joints, especially in his hips and shoulders, showed severe arthritis. The muscle attachment points on his bones, what anthropologists call enthesial changes, were enlarged in very specific patterns. He had spent enormous amounts of time sitting with his legs extended in front of him, leaning forward with both arms outstretched. The most likely explanation was pottery work. The posture matched what an experienced potter would have held while shaping clay at a low wheel day after day for decades. This is what made the burial strange. A man sealed inside a ceramic pot inside a rock-cut limestone tomb was being given an elite burial. Most Old Kingdom laborers were not buried like this. They were buried in shallow desert graves with little protection from animals or weather. A ceramic pot inside a limestone tomb was the kind of treatment reserved for people who mattered. So the man in the pot was someone whose hands had been worked raw for decades, but whose family or community had still arranged a high-status burial for him. He may have been an exceptionally skilled craftsman, or his trade may have carried more prestige than archaeologists previously realized. For more than 120 years, the man from New Wairat sat in a wooden crate in an English museum, unidentified, his story compressed into a tooth, a skull, and a few inches of dust. In 2025, that story finally got told. He was an Egyptian, born and raised in the Nile Valley around the time of the first pyramids. His ancestry stretched from the Sahara to the rivers of Mesopotamia. He worked with his hands. He lived into his 60s. And he was buried with care in a sealed pot inside a stone tomb because the people who knew him decided he was worth it. If you want to keep watching the moments when ancient DNA quietly rewrites everything we thought we knew, subscribe to Origins Revealed. The next story is already coming.